Hi, Rivali. Thanks for inviting me over from Siglent, USA to meet you here at Electronica in Germany. Have you seen our new SDS7000 series 6 GHz oscilloscope?
Welcome, Chris. Yes, I've seen that. The jump to 6 GHz is substantial, particularly for those who involved in high-frequency applications. This kind of bandwidth actually gives them numerous possibilities, particularly for high-frequency digital design and RF applications. So in your view, which applications will be most impactable by this enhancement?
Yeah, I think the RF applications are really going to be critical. Being able to do some real-time analysis of high-frequency signals and mix that in with design and debug is really the power of this instrument. What industries do you think this is going to serve?
I see significant potential in aerospace and automotive sectors. As you rightly mentioned, I also see potential in RF applications for their numerous possibilities. Actually, they are certainly a key beneficiary. But when we are talking about autonomous radar systems, they particularly operate at higher frequencies. So this kind of bandwidth actually gives them for their thorough testing. And when we are talking about aerospace sectors, they uses radar and satellite communications will also highly benefit from this 6 GHz capacity. Additionally, from all of those applications, it's also valuable and important for advanced signal integrity testing for their high-speed digital circuits. What do you think now the engineers would change or shift how they used to approach those designs now?
Yeah, I think signal integrity really sums it up nicely, right? The 12-bit front end on this instrument really gives you a great capability to switch between noise and bandwidth, get up to the full 6 GHz with really a great noise footprint. So, these signal integrity issues like emissions that engineers might see, higher speed clocks, reflections and jitter on those clocks are great debugging tools that you can now continue to expand with this new instrument and new capability.
You raised excellent point here. Testing high-frequency components such as mixers and oscillators now will become far more efficient. Furthermore, now engineers will be able to analyze peacefully the high-frequency speed communication protocols like MIPI and DDR memory applications. This bandwidth truly unlocks the wealth for untapped potential here.
Yeah, the super deep memory in this instrument is really a powerful tool. Allows us to do some real-time analysis, allows us to really dig into those high-frequency signals, but also look at slower frequency signals, mid-range digital and analog signals, in a bunch of different ways with the analysis tools and packages that we continue to add to this instrument. How do you think this sets Siglent up in the competitive market?
Undoubtedly, it places us more in a competitive stance when compared to already established brands. Siglent has always been a reputation for its strong performance and its accessible price point. Now with the addition of 6 GHz bandwidth, we are poised to compete with advanced market segments. As we always maintain a balance between price and performance, now we maybe go to option for engineers who wants to explore higher frequencies. What do you think will be the next on the horizon for Siglent?
Great question. I think as we continue to expand bandwidth and frequency, the instruments need more and more application techniques and modes and tools. So adding those capabilities in firmware, adding new accessories for engineers to access those applications is really the next step as we continue to move past 6 GHz.
Totally agree. The release of SDS7000 with 6 GHz capacity sends a clear signal that Siglent is more serious about entering high-performance markets. Maybe we will. I'm excited to see what's next. Maybe we will see 10 GHz or even a higher bandwidth in the near future.
Siglent Technologies.
Every bench.
Every engineer.
Every day.